welcome everyone to the Intellify Databricks webinar on disrupting insurance using AI and ML. I think I'll kick it off now. So by way of a little bit of an agenda, I'll start with an introduction to Intellify and to myself, move on so I guess draw the lens back a little bit and talk about the shifting nature of the customer-insurer relationship as a motivation for what I'm going to then be discussing. I'll then go through an Intellify customer story, specifically on something that we've delivered for a large health insurer, NIB, and then work my way through a few specific use case discussions, so around underwriting, around risk premium pricing, and lastly around low, no-touch claims journeys, and really examine how machine learning and advanced analytics can benefit each of these areas. Lastly, I'll pass over to Jonathan from Databricks, who will go through a bit more detail on some of the technical aspects of Databricks architecture and its platform, and run a demonstration of building a deep learning vehicle damage classification model for claims handling. So first, a little bit about me. My name's Cam Cairns. I'm a principal consultant here at Intellify. My background is in data science and machine learning. I've worked 6 years as a data scientist, data science manager and machine learning engineer across the FSI industry, both here in Australia and back in the UK. Prior to working at Intellify, I ran a number of different data science teams at CBA, and then before that I was involved in building out a new brand at a large personal lines insurer in the UK in London. I really love focusing on end-to-end ML productionization in this space. And by way of introduction to Intellify, we're a machine learning consulting company. We're an AWS machine learning consulting partner and advanced AWS public sector partner. We do a range of deliveries, so everything from strategic advisory all the way through to consulting and building of ML models and platforms and productionization systems through to managed services. We won the AWS Partner of the Year for data analytics and machine learning last year, and we have delivered over 100 ML projects in over 5 countries. I have a few outcomes here of projects we've delivered in the past. I guess the most relevant ones for insurance around time series forecasting, natural language processing, OCR, price optimization, churn prediction, personalization. So look, I thought I'd sort of frame this, the kickoff as a bit more around digital disruption. So, you know, as we enter this new decade, I think the insurance industry is in a really interesting position. You know, the traditional insurance business model has been really resilient in the face of some pretty big changes brought by data and technology. You know, think of the things that have affected retail, media and entertainment, comms, software, that sort of thing. But if we sort of survey the landscape in 2020, insurance seems particularly susceptible to potential future disruptions. And to my mind, data and technology holds the key to empower insurers to be able to manage this change. Now, this quadrant on the left-hand side was the result of an Accenture piece of research and survey, and found the insurance sector is actually one of the areas that are most susceptible to future disruption. You know, what we're seeing is, and this has already started, but but it will only accelerate, is a reweighting of insurers away from a payer-only relationship to also inhabit that partnership and prevention roles. You know, all of that, you know, that transition is driven by better understanding of customer data, better understanding of customer risk, better understanding of how to produce compelling value add-ons that keep a customer with a particular insurance brand. And ultimately, insurers of the future will play much more of a risk avoidance role and less of a risk mitigation one in the way that they currently do. So now jumping to a bit of a discussion around what some of those big changes are. Now, I think, firstly, as mentioned, what we're seeing is a move from transactional to advisory. So traditionally, insurers have focused on that tactical, low-level engagement with customers, and moving now more to strategic, high engagement customer interactions. And there's benefit in for a number of reasons for this. Firstly, having high engagement interactions with customers increases their stickiness and reduces their likelihood to churn, assuming they have a positive interaction and relationship. But secondly, from an insurer's side, increasing the number of interactions and engagements with a customer enables an insurer to get more data points on a customer and understand their profile and their risk far better. Insurance now tends to be reactive. A customer has a claim and then lodges that claim, and then the company will react in response. The flip side of that is movement more towards being proactive, better tracking, and having better predictive capabilities. Insurance now tends to be very broad segment-based, so everything from products, pricing, discounts are all broadly aggregated across certain risk profiles. And just like in almost every other industry, there's a real drive towards better personalization and better tailored engagement with individual customers. And then lastly, we're seeing an increased move from being product-based, where there's a predefined set of product features with standardized pricing and placement, to being more solutions-based. So moving more into that exotic or different ability to price risk enabled by better customer data. Now, I just wanted to have a little chat around a customer story and project that Intellify has delivered quite recently, so back in February. And this was with NIB Health Group. So NIB is a health and medical insurance company, covers over 1.6 million Australian and New Zealand residents. And they brought Intellify in to specifically work on a really consequential problem of theirs, so outstanding claims forecasting. And we were focused in this case on the private hospital modality. Now, this problem is really important. It goes into everything from reserving decisions through to pricing and business strategy around how to target particular customer sectors and segments. And in a 6-week engagement, Intellify data scientists worked with the NIB actuarial team and some of the other data teams at NIB, and built a machine learning time series based approach to approaching that problem. This was built using Databricks and AWS. We also incorporated external and publicly available data sets that hadn't currently been used in the existing OSC, actuarial OSC model. And what we ended up with was a really substantial reduction, a really nice reduction in the error compared to that actuarial benchmark in the 2-year private hospital OSC forecast. I think this is a fantastic outcome and a fantastic project to demonstrate some of the value that that machine learning can bring to the insurance space, even in those traditionally actuarial spaces. Now, I'd like to sort of jump further into a bit of a discussion around how ML and can impact and benefit the pricing and underwriting space. So underwriting is a complex process. And ultimately, it's a process of discovery, segmentation, and grouping. I see it as sort of 3 very broad steps. One around discovery and identification of relevant information around a customer. Secondly, the ability to assimilate all of that relevant information into a picture of risk of that customer. And then lastly, deriving a quote and pricing that risk profile. And so different insurance sectors and different organizations will certainly have some various nuances around the underwriting process. But ultimately, those 3 stages are sort of key. One thing I want to emphasize here is that there are lots of independent steps in this underwriting journey. There's no single solution, and it's not the right way to be thinking about machine learning in insurance in general, to go, look, we'll just build a one model and then that'll solve underwriting, or that'll solve this problem. Rather, I think the right way to think about it is machine learning offers a series of specific tools and applications. An organization should look at their various journeys, so like the underwriting journey, and identify steps or problems where ML can offer, really improved benefit, and then use machine learning and advanced analytics to augment human underwriters. Remove some of the work that human underwriters are less good at, so thinking repetitive things or steps that require assimilating large amounts of information to make a decision, and then direct those human underwriters to spend more time on value adds that humans are really good at, and so interacting more with customers, acting as an advisory role, and in that similar vein. So just going back to this first step, discovering identity and identifying relevant information. I think when we're talking about opportunities in underwriting, we have to start with data. Ultimately, the job is, how can we get the best view of a customer's risk? And I think every underwriter in each insurance company should really be starting to ask that question: what other data sources exist that would provide a better view of a customer that we could utilize? Traditionally, insurance companies' underwriting operates off a historical set of questions and categorical features, but there's a huge amount of additional information that's coming online, where there exists the technology and the algorithms and the tools to be able to leverage that and bring that into a view of a customer risk. Specifically, how could we as an insurer better leverage unstructured data? Do we have image, do we have text, do we have video, do we have satellites to understand the position of customers in? Can we use real-time data? So things like telematics, IoT sensors, telematics in auto insurance, IoT in property or health or life insurance. And last question, can we build better proxies for missing data in a customer? I think this one's a really interesting and key one for underwriting. There's always a tension between having trying to push towards a great low touch, low friction experience from a customer as they apply for a particular insurance product, against us obtaining enough information and data from a customer to give the best possible view of that customer's risk. And so there's a trade-off there, but one where the right use of machine learning, data analytics, and data infrastructure can help fill in and create better proxies of data to both enhance that view of a customer risk and reduce the amount of friction involved in trying to retrieve data from customers. So I thought I'd run through like an underwriting journey and sort of point out where some of the data and machine learning opportunities exist. So if we start from receiving the submission, well, there's a process of standardizing and streamlining that data. Building a good chatbot channel is a great way to scale out another way of interacting with customers in a way that scales to any number, and to improve that friction-free journey. And lastly, is there an ability there to leverage historical customer data? So if you have customers that you've already seen before, already quoted before, is that data being stored, and can it be used to augment and improve the existing submission? Second step now, entering data, various things around automating data passing, using OCR, pulling and assimilating third-party data sets, APIs, or streaming data like sensor and IoT. AWS has some fantastic tools around OCR, so Amazon Textract, Amazon IoT products, and various things that are really good for bringing this type of data into a data platform. Now we move to analyzing risk, triage, fraud detection. So this will be a similar discussion when I go through the no to low touch claims journey. But I think a key way of both improving a customer journey and reducing the friction for a large segment of those customers is the ability to be able to identify, standard application processes. So using machine learning models to identify, the characteristics of a standard application, and then routing them down an automated process that produces a quote and creates a policy without any human interaction. And then on the flip side, identifying those high touch applications where there's ambiguity or other things need to be investigated, and routing those to a more manual or human intervention process. using machine learning to be able to predict risks with more data and more data granularity, and I'll go into that in a little bit more detail on the next slide. Using additional data sources like images and videos to improve that accuracy. And lastly, if you're talking about trying to automate or reduce the amount of human interaction on certain processes, there needs to be a commensurate improvement in fraud detection. Fraud detection using machine learning is really a state of the art. It's a fantastic way to approach that problem. And if you're not currently using that for fraud detection, both in claims and in underwriting, it's definitely something to be investigating now. We move now to producing a quote. So using machine learning algorithms to generate that quote using that full picture of a customer's risk. Again, I'll go into that in a bit more detail in the coming slides. And on the flip side, for those high touch paths, making it easy for a human underwriter to identify key risk factors and provide sort of a case report that they can then easily use to investigate and update. And then lastly, around binding policies, just around automating system processes. So now just jumping to a bit more detail on risk grouping. This fundamentally is not different from what a standard underwriter is doing now, and with the standard actuarial tools or underwriting tools. The difference here is really one of scale and speed. Machine learning algorithms are able to bring in much vaster data sets, and because of that, build out a more nuanced vision of a customer's risk profile. For example, in this top figure here, I've got an illustration of a tree-based algorithm. So it's something like a random forest, a gradient boosting machine like LightGBM or XGBoost. What the algorithm does here is brings in input features as well as historically the target or the what historical customers' risk has been, and then produces a number of splits and groups or splits customers based off the ability to limit or reduce a loss function. What that means is, it's a scalable approach to be able to bring in more data points and build out a more nuanced picture of a customer's risk. This is illustrated in this bottom figure. So if we imagine group one has a loss ratio of say X% based off 300 data points, by bringing in more data points, we're able to split that group into further subgroups and get a better uplift in the overall loss ratio spread and a better more accurate view of a customer risk that'll flow into the risk premium price. Typically, when you're talking about risk premium modeling, your actuarial approach is to use a GLM, and GLMs are a really powerful, good tool. However, the way machine learning models are actually able to bring a whole lot of additional benefits really to any regression style problem. If we're sort of thinking about use cases in that actuarial modeling and pricing space, really anything where you're doing a regression style problem is a candidate for benchmarking against a suite of machine learning models to get a feel for the potential performance improvement. The robustness of ML models enables a relaxation in some of the model assumptions, particularly around output distributions and that sort of thing. And because of this, we're able to use and utilize more complex data sets and ultimately, ideally, build a more accurate model of a customer's risk premium. Ingesting a range of data sources, so everything from internal data, like standard stuff that would be going into a GLM, but also other things around external data, so government data, social media data, any customer-provided streaming data, etc. So it's good to ask this question, like, how is this different from a traditional approach? I've had these conversations with quite a number of different actuaries in different roles. I think there's sort of two key things, and absolutely, actuaries and actuarial teams are dipping their toes and using a range of these algorithms, although we haven't seen that sort of move or adoption fully yet. So I think there's sort of two big things. One is that robustness to data nonlinearity. This is illustrated here in this figure. You can see the blue line is that true response, so actually how that age factor relates to claim amount, and then a couple of different fits, linear and log. So the log fit is sort of like a GLM fit here. And so GLMs can handle some types of nonlinearity, but for a standard sort of real world nonlinear response, that's where machine learning models can really accelerate and be really very powerful, particularly on the edges of distributions. So the edge cases of customers, that ability to fit places of true nonlinearity can really improve an organization's ability to price risk. Secondly, I'd say that ability to better handle deeper and wider data sets. A lot of the existing approaches have certain requirements around how data is aggregated and the types of data, as mentioned. So having a technique or a tool that allows you to approach a problem in a different way with different types of data can really improve that ability to ultimately come up with a risk premium pricing. Now I'm just going to jump to discussing no and low touch claims. So let's start by asking, why does this matter? Well, in a recent survey EY did on consumer insurance, 87% of policyholders said that they believe claims experience impacts their decision to remain with insurers. And this makes sense. Obviously, it's almost like the first time or some of the only times a consumer will interact with an insurance company is if they have to make a claim. There are two key considerations that came out of that survey for what customers are looking for. One is around speed of settlement, and the second one is around process transparency. And I think both of these considerations can be enhanced and improved upon by using advanced analytics, machine learning, and AI. From an insurer's perspective, there's actually been estimated that up to about 30% cost reduction in a customer claims journey from utilizing automation. So there's definite potential savings from an insurer's side as well. So let me run through a few of these potential use cases and how AI ML can unlock a seamless claims journey for a customer. So if we start even before a claim has occurred, and this is sort of emphasizing that shift away from a payer relationship to a partner relationship, using IoT and sensor data to identify high-risk situations and help a customer navigate those. Utilize additional health, lifestyle, additional data to better engage customers and move them or nudge them into a place that leads to better, better, less risky outcomes. And engaging behavioral analytics to drive preferential outcomes. If we then jump now to thinking about what happens with the first notification of loss. Again, chatbot interfaces can help to accelerate and streamline customer claims parts. There's a startup insurer in the US, Lemonade, who are sort of famous, I guess, at this point around their very rapid claims journey, so on average 3 minutes, and they use chatbot interfaces heavily along with OCR and a few other machine learning tools to speed that up as much as possible. As I mentioned, OCR form processing to pull information out of digital documents and pictures of documents, and ML for accurate processing time prediction. So being able to give a customer a good understanding and a transparent understanding of how long a claims journey could take. Then jumping now to claims triage and segmentation, very similar to underwriting, using machine learning models to identify claims that can be automated as much as possible, and routing higher touch claims to claims assessors for further work. Similar thing around the claims fraud detection here. And then lastly, around claims assessment and resolution. So a couple of things around using deep learning models to identify and define damage based on photos provided by customers. Now, this is something that Jonathan, who I'll be handing over to shortly, will demonstrate using the Databricks platform for vehicle damage, but also bringing in OCR and invoice and billing data, along with workplace planning and scheduling optimization for claims stuff. Just before I hand over to Jonathan, I think the other part here, and something I haven't really talked a lot about, but I can't emphasize how important it is around having, you can develop machine learning models and advanced analytics capabilities locally, but to have a true impact on an organization, that needs to be productionized, and that needs to be brought into a business as usual setting. And so that's really where a lot of the time Intellify spends is around building out that capability. So simple platforms, reliable engines that scale to potentially thousands of models, flexible, cost efficient, and ones that enable good oversight from a regulatory perspective and a model training perspective on being able to track model drift, model performance, trigger automatic retrainings and parameter optimizations. But I'll hand over to Jonathan now to give a bit more of a discussion on the Databricks platform and demonstrate that deep learning model.
Hi, everyone. Thanks, Kim, for his presentation about ML and AI in the insurance space. So now we'll go a little bit deeper into the technologies that enable you to be able to do that. We'll be covering how to build an image classification system that can help with automating the motor claim insurance process using Databricks and AWS today. A quick introduction. My name is Jonathan, and I'm a solutions architect at Databricks. Before this, I've been working as a data scientist across multiple domains with experience building applied data analytics solutions in different industries. Interestingly enough, for this audience today, I'm also an associate with the Actuaries Institute, but I've taken a slightly different path compared to you guys. So before we dive into the demo, I just want to take a bit of time and tell you a bit more about Databricks. So who is Databricks? We help companies solve the world's toughest business problem by offering a unified data analytics platform that brings together data engineers, data scientists, and business analysts. At this point, you might be wondering what makes us different from other companies who are also throwing these buzzwords around. We are all numbers people here, so let's look at the data and let the numbers speak for themselves. With over 6,000 existing customers, 450 partners, and hundreds of thousands of users, the reality is that we've been doing this for a long time, and we have led a lot of development in this space. Most of you might know us as the creator of Spark, but we have come a long way since then. In the past year, we have also open sourced Delta Lake for building scalable and performant data lake, and MLflow for managing the machine learning lifecycle. We have always believed in the open source model, and we are providing a lot of thought leadership in this space. And on top of these innovative open source technologies, we offer a managed service that enterprise customers such as yourself can leverage these innovations without investing a significant amount of time and effort into setting up the lower level infrastructure, and instead have your team focus on what is really driving value to your business. Here are a small sample of our customers, and we pride ourselves in enabling innovation across a broad range of industries across the globe. You can see that we support global conglomerates like Shell and Apple, to government agencies in the public sector, to new startups around the world. But I want to highlight the financial service sector here today, which is one of our fastest growing vertical within Databricks. Not only do we have customers like the big banks, we also have support small and new fintechs that are popping up around the world. This goes to show that Databricks is a platform that is agile enough that can scale with your needs. So what are these customers using Databricks for? Here are the key use cases that companies are building on our platform, from more traditional predictive problems like risk prediction, forecasting, and Monte Carlo simulations, to building their entire data hub on Databricks so that they can do proper customer 360, improve customer experience, and product recommendation. I won't go too much details into each of them, as you have probably heard quite a bit from Cam today already. Here are 3 customer examples that might be of interest to you. We have helped HSBC build a personalized mobile app for payments, and by aggregating their siloed data set into a single data lake, they're able to build fast data pipelines, which enable them to build ML models at scale. As a result, their PayMe app is now the #1 app in Hong Kong, with over 60% market share. FINRA is the financial regulator that is responsible for protecting investors by ensuring that the US security markets operate in a fair and honest manner. They use Databricks to process billions of trading events in order to detect fraudulent activities. Finally, in the insurance sector, we have Nationwide, who is hitting some scale limit with the traditional actual modeling tools. So Databricks fits in by providing a managed platform that is optimized for big data processing and machine learning to help them improve their existing actual models onto a modern data architecture and enable them to deliver results much faster. When we look at these customers, we see that they're able to take control of their data and successfully build data science and analytics capability on top of their massive data lake. The ability to leverage data to unlock business value is what sets them apart from other companies in the market. But we all know it's not as simple as this looks. Most organizations fail to get value from their data because the reality looks more like this. We see that there are silos at every level, from the data to the technology to the people, and that is what Databricks is here to solve. I don't know about you, but I have lived through a fair share of pain stitching these technologies together, wondering why I'm spending my time setting up infrastructure rather than working on the data. From our experience, we found that the companies today are facing 4 major challenges when it comes to unlocking business value from data. First, getting on top of your data is tricky. Data used to be structured and small and relatively easy to deal with. The modern data sets come in all shapes and sizes, and the traditional approach can no longer really keep up. Second, using machine learning to solve business problems is hard, and moving machine learning projects from R&D into production is even harder. The lack of ML lifecycle management tools meant most innovation ends up never making their way to a solution that improves the business. Thirdly, traditional tools can no longer keep up with the data volume today, and companies are forced to run BI on a fraction of the data. Lastly, most of the solutions out there are not enterprise ready, as they don't have an adequate level of security and governance in place for companies to fully rely on them. And Databricks is the platform that we have built to help customers solve this problem, and you can see how it works later in the demo today. So to summarize, Databricks is a unified data analytics platform that securely integrates with your cloud ecosystem. Our unified data service enables you to process and curate all your data into an open data lake. The data science workspace brings data engineering, data science, and BI into a single platform. And most importantly, with a unified platform like Databricks, we're breaking down silos between your team by giving you the tools to easily collaborate so they can help you realize the value in your data. So how do we integrate with AWS? On the ingestion side, we integrate with a range of data services like S3, messaging queue like Kinesis, or database like Reshape and RDS. And on the consumption side, we integrate with tools like SageMaker for model ML deployment, writing data back into cloud data store like DynamoDB, or integrating with analytics service like Athena. On the management side, we integrate directly with the AWS platform so you can leverage your existing cloud security like SSO and IAM, and you can also get Databricks directly from the AWS marketplace. If you're interested in learning more, we have an AWS Partner Network program where AWS and Databricks will help you build out a full-on solution. So please contact us for more. So let's get to the demo. So in today's demo, we are going to see how we can accelerate the claim assessment process using computer vision. The problem we are trying to solve here is that we don't want to have too many people spending time to classify the severity of the damage of a vehicle in the event of an accident. So we are trying to train a model to do it for us. Basically, we want to be able to take a picture of the vehicle from the incident and have a model tell us the severity of the damage. The technique we will be using today is called transfer learning. The reason why we are using transfer learning is that it takes a tremendous amount of data and resources to train an image recognition model from scratch. So what we want to do here is to leverage an existing model and retrain the last layer of the neural net to do the classification, which we'll talk about in a bit more details in a little bit. So let's, in terms of data, we started with the Stanford car dataset, a database of car images that is a great starting point for us. But we also need images of damaged vehicles so that we can train the model to distinguish the difference. So for that, we scraped into the internet and we believe we can train a classifier that is able to tell us whether a vehicle is damaged or not based on a picture. It's worth noting that this example doesn't really take into account the costs of fixing the car. Of course, a bumper dent on a Ferrari will likely cost much more than replacing a door on a Toyota. So that can be a challenge for you to play around after this session. So let's have a look at what we need to do. First, we want to be able to process the image so that it is ready for our machine learning to take in. So in this case, you can see that I've already loaded in a number of car images inside the car directory. And we are loading in some common Python library in order to help us to process these images. First, we want to be able to resize the picture into the fixed dimension, which is the input of our ResNet model, which we'll talk about in a little bit of details later. So let's have a look at the images. So first, here we have a number of different car images that are in good condition. So here is, we need to understand that we need to have the data set with a variety of different cars in different angles, different colors, so that we are actually training the model to distinguish between a damaged car and a good car, rather than just a side profile of the car or the front profile of the car. So as you can see, we have different lighting conditions, different angles, different color, just so that the model can learn to distinguish the differences. So on the other hand, let's have a look at the damaged car images. In this case, we also need to make sure we have a wide range of car different damages, from a dent in the door to the whole car being totaled, for the same reason, so that we can compare and contrast the two. So what we're going to do is basically resize the image so that we can store it back into our DBFS, which is our Databricks file system, for access later on. So with Spark, you can actually read an image file by using the format image, which is quite handy, which means you can also use enable SQL capability to read those data set. So in this case, I'm reading in both the accident data and the car data with a label of 1 being damaged and 0 being not damaged. And I'm creating a temp view called cars. What they allow us to do is to be able to query the data set using SQL, which is quite neat to be able to see the image of the car and also any other data labels that you've added towards it. So now that we have our data prepped, we need to go into building the machine learning model to be able to do that. So let's go to that part. So a bit of context, this is what we learn about from transfer learning. We want to take an existing neural net and be able to train the last layer to do the classification. So in this case, we're going to use the ResNet 50 as our starting point. It is a convolution neural net with 50 layers that was trained over 1 million images with the ImageNet database. And what we want to do is to take all the good and great learning that the model has trained on and remove the last layer to do the transfer learning to be able to pick up whether the car image is damaged or not. So this is exactly why we need to resize our image to the starting point that fits into the ResNet model and retrain the last layer to do what we want it to do. Here are some import statement. It's worth noting that using our Databricks ML runtime, packages like PySpark, TensorFlow, Scikit-learn, all those are already installed and made available for you, so you don't have to worry about managing those dependencies and libraries when you're using Databricks. And we'll also use MLflow a little bit today to see what the difference and what it is actually doing. So what first we want to do is to access the image database. So we are reading the format as a binary file from our car thumbnails and our accident thumbnail directory, which you have seen before. And we want to create the label, see how it looks. So this is what the data looks like. So the content is now in binary format. And we want to load the ResNet 50 model for transfer learning. In this case, we're going to specify include the top layer as false so that we can do our transfer learning on the final layer. And this is where we'll start. So what we want to do here in this case is do a bit of pre-processing and turn that image into a feature, something that the model can understand. And we'll distribute that workload across the entire cluster to improve our performance. So first, we want to convert the image into input vectors. As you can see, this is the content. And this is the label. This car, in this case, this car is in good condition. And we have turned our image into basically a feature vector that the model can understand. We will do, just like any machine learning model, a split between training and test set, so we can compare and contrast the results to make sure we're not overfitting. So in this case, we have 446 images in the training data set and 200 in the test. We're going to use a logistic regression model to do the classification. In this case, we're specifying some parameters that inputs go into the logistic regression. And this is basically how we train and fit the model. Of course, the label column is what we're predicting. In this case, is a 1 being a damaged car and 0 being a good condition car. So you can see that there are a few interesting steps happening here, which is MLflow log algorithm, log parameters, log model, and log metric. What is interesting is that by adding a few lines, we are using MLflow to be able to keep track of what model we are building, and we can come back to the result in any time in the future. And in this case, let's see, this model is pretty good. It has a model accuracy of 88%, but we need more diagnostic than just the accuracy number. So let's have a look at what else we can do. One common way of diagnosing a model is to use confusion matrix to understand the false positive and the false negative rate. And here we can see sort of the distribution of that. And of course, ROC curve gives us a good idea about how it performs and how we should pick the cutoff if we do want to turn our prediction from a probability into a 1-0 as a binary output. So what we can see here is that this is the distribution of the predicted outcome. What we're actually interested in maybe is to help our claim processor triage these claims is to split them into different categories. So here we're going to put into small bucket from minor to major to critical and severe. So we think those will be the right cutoff point. So in this case, we're going to write a UDF function that picks up basically if the probability is below 0.6, it's a minor. If it's between 0.6 and 0.7, it's medium severity. If it's between 0.7 to 0.9, it's severe, and anything above that is critical. So that our claim processor down the line can go and have a look at which accident they need to look at first. So we are basically applying this classification onto our prediction. And let's see what it looks like. So here we can see if we are reading from our output, which is from the car accident table that I've created, you can see the probability. So in this case, if you're looking at that, all of these are pretty damaged so that they have a really high probability of being in the damage category, which is correct. But what we want is to actually make it easier for people to navigate and look at the different severity. So what we want to do is using something called a widget. In this case, we have created a drop down. So your final user of this data set can have a look and define what severity they want to look at. And that will give you basically a summary of these are the cases that you need to look into. We can also turn this into a dashboard, makes it easier for you, for your downstream users to go and navigate this data set. So in this case, it's the same output with the same drop down. So in this case, if we turn it into severe, it will reload the data set and shows you the accidents that are in the severe category. Yeah, so in this case, as we defined earlier, is between 70 to 90%, and this is what we are having here. So now you sort of have a model running. You want to be able to share this information with your colleague. What is it? What they want to know is not only the code, but also what are some of the summary information that you have, which brings us to MLflow. So in this case, if you click this run, it will show you the run that we have done. This is particularly useful when you're sharing information and making this model deployable and repeatable. So if you go into an MLflow run, you can see the parameters that you have used to train your model, the accuracy, and also the model itself, which means you can register this model into our model registry, which makes it available for other people to use within the organization. So the model registry is a way for you and your team to catalog all the models that you have within the organization, make it discoverable to other teams, and make it repeatable for your downstream machine learning engineers or business user. So in this case, it not only allows you to document what this model is about by adding some description, it also gives you a process of deployment. So as I just created this, I want to make sure I'm not breaking anything. I want someone to review it so I can request a transition to production. And of course, everything here is ACL, so only certain team member will have permission to do certain actions. In this case, if I'm a team member, I'll put this into production, and then my team leader will come in, be able to review and approve. So in this case, if we approve this into production, that means your downstream machine learning engineer only need to know the name and the stage that they want. So in the code that imagine your downstream engineer will use, they will reference, I need the car insurance model, the latest version in production. And they will be able to pick up that model that you have and be able to score it on incoming data set rather than having to worry about what actual algorithm that you use, what are the process. But from an auditing point of view, there's also activity tracked. So which means you always know when a certain version is being moved from staging to production. And if there's anything wrong, you can always go back and audit and make sure you understand what happened. So that is how you can quickly build an image classification model using Databricks and MLflow on top of Databricks. Thank you for your time today.